A few lessons ago, we talked about linear inequalities in one variable. And I want to go back and review that because everything that we learned in terms of definitions of what a solution is and how we represent that solution on a graph holds true when you take it to two variables. I know I've said it in this video series and I say it in my classes all the time. Math is consistent. So what you learn in one area of algebra will transfer over to another area. So suppose you had not that. Okay. 2x plus 1 is less than, 6. Okay. A solution, we'll go back to our definition of solution, is the value, or I should say are the values of the variable that make the inequality true. Okay, and then we go about solving the inequality. So we have 2x plus 1 is less than 6. We subtract 1 from both sides. I don't know why I did this. Why did I do this? 2x is less than 5. Divide both sides by 2. And I'm going to go ahead and change that over to a decimal. So x is less than 2.5. Now you think, okay, well, what are the values of x that would make that true? So let's go ahead and put the 2.5 on there. Any values of x less than 2.5, so that would be this side of the 2.5. So it'd be numbers like 2, 1, 0, -1, but also like 2.3, 2.4, and so forth. And so the way we do that is what we do is we would color in all those points, except there's an infinite number of points, so we're not going to do that. So we do this thing called shading. Now, the 2.5 marks the boundary between the values of x that work and the values of x that don't work, or the values of x that are solutions or give us true statements, and the values of x that are false and don't satisfy the inequality. So we need to mark the 2.5. But the 2.5 itself is not included in the solution. 2.5 is not less than 2.5. And so we need a way to mark the boundary without coloring the boundary or shading the boundary the way that we do with the solutions. Now, I want you to notice a couple things because this is about to transfer over into two dimensions. Notice that the boundary divides the number line into two sections. One that is true and one that is false, okay? One that doesn't work and one that does work. Also notice the idea that there are an infinite number of values of x that will make this particular inequality true. So we're about to do the exact same thing, except we're going to do it in two dimensions. And it really transfers very, very nicely over. So I am going to put an inequality on this graph, or on this coordinate plane here. And what we're going to do is check to see if specific values of x and y are true or are solutions for that inequality. Okay, so we're going to start with the point 0, 0. Let me do that in a different color. We'll do that in red, okay? So we want to know, is the point 0, 0 a solution to this inequality? And we do this exactly the same way we would do for equations back in the day. We take x is equal to 0 and y is equal to 0, and we plug it into the inequality, and we see if it gives us something true. And I have to caution my students, be careful when you're evaluating the inequalities with the negatives. It is easy to get these backwards with the negatives. So if you need to, you can picture on the number line, like 0 is here, -2 is here. Is 0 greater than or equal to -2? Yes. Okay. And so I'm going to go ahead and plot that point there. Now, if you need to pause the video to copy this work, if you're taking some notes, please do so. I'm about to erase it. All right, next point that we're going to check is the point 0, 1. And so this time we're going to plug in 0 for the x and 1 for the y. And we end up with -3 is greater than or equal to -2. So you can kind of picture like -3 would be here, -2 would be here on the x-axis there. And that is a false statement. So the point 0, 1 does not work. And again, pause the video here if you need to write that down. Last point that we'll check is the point 2, -1. So x is equal to 2, y is equal to -1, and we end up with 4. Now just be careful here, a negative times a negative is going to give you a positive. And you can probably tell without even going any further, like 4 plus 3, whatever that is, like, which is 7, but it's like a 2 positive numbers. If you add 2 positive numbers together, you're going to get something greater than a -2. And so that's going to be true. So that's 2, -1, like that. Now, what I've done in my classes before when I'm doing an exercise like this is I'll have like the class do like 20 points, okay? And what you notice is that all of the points that are true fall on one side of the line, and all of the points that are false fall on the other side of the line, and the line itself is the boundary between the points that are true and the points that are false. Exactly the same way that we see it in one dimension, except with the one dimension we have a point, and that point is the boundary between the values that are true and the values that are false. In 2 dimensions, you have a line, and that line is the boundary between the values that are true and the values that are false. Now, in exactly the same way with one dimension, where we shade in the values that are true, we do the exact same thing with a 2-dimensional inequality. And so instead of doing like an infinite number of points, we shade it in. And usually just something like this that clearly indicates which side of the line is being shaded. Be careful. Sometimes students will stop when they get to like the x-axis or the y-axis. They won't want to change, like shade over it. So you have to make it clear that you understand which line is the boundary line, which in this case is the line 2x minus 3y equals -2. And that's what this line is right here. This line is the graph of the equation, the equal to part, that serves as the boundary. Okay, so what you should be seeing here is like it's a connection between the one-dimensional half of the plane, like on one side of the line is going to be true, the other half is going to be false, and you color in the side that's true. And you can pick individual points, like we did, like with the 0, 0 and the 0, 1 and the 2, whatever that one, I don't even know, I think I was making random dots at that point. But you can pick individual points, plug them in, and see whether they're true or whether they're false. Now, we would be interested in a shortcut because that can be kind of a tedious process. So we'll explore that in a little bit. Quickly, let's go back to our horizontal and our vertical lines. We don't see them very often. I don't think we've really looked at horizontal and vertical lines for actually quite a while now. So let's take a moment and just quickly refresh those. Suppose you were asked to graph x is less than -3. Now, if it were in one dimension, okay, you'd plot the -3, you would do an open circle because it is not included, and you'd shade everything to the left, okay? So how does that translate when you're in 2 dimensions? And like, how would you know if you're supposed to do it in 1 dimension or 2 dimensions? Context of the problem. So if you're provided with a coordinate plane, you're probably going to do it in 2 dimensions. If you're provided with a number line, it's 1 dimension. So same deal. We've got x is -3, which is right there. And we are going to shade everything to the, except we're going to do it in 2 dimensions instead of in 1 dimension. So instead of just shading right on the number line, we're actually shading above and below because we have that y coordinate to take into consideration. Now, this raises the question, what do we do about the line? We know if it were just on the number line, we would use an open circle to indicate that the -3 was a boundary, but not actually included in the solution. we've done graphing vertical lines, but we do know that if I have a solid line, that would be the line x equals -3, and we know in this case it is not actually equal. So that leaves us with the problem, how do we draw a line but not color it in? We need the two-dimensional equivalent of the open circle. And the two-dimensional equivalent of an open circle is, well, let me, come on, let me do it. There we go. That was really weird. Okay, so it's kind of like we do the inside of this, we do the circle. Well, I can do this better. You do a circle and you color it in, all right? But we don't want to color it in. We're going to do the line and then we make it dashed. Sometimes you'll hear people say a dotted line or like dotted or dashed. And that way we can put the line on the coordinate plane but not color it in. So that's the equivalent of the open circle. And so if you've got a boundary line, but it's not equal to, it's not actually included, you would draw the line and you would make it dashed. Easier to do with a pencil, easy to mess up with a pen. And it same works for horizontal lines. So if you had wanted the graph of y is less than or equal to 4. Now the line is included because of the equal sign. So you basically have y is less than 4 or y is equal to 4. Like both of those work. And so we would do a solid 1, 2, 3, 4, a solid horizontal line. And just think y is less than. So we got to kind of turn our number line around. We usually do our number lines horizontal. Now our number line is vertical. So you want to think on your y-axis, where do you find numbers that are less than? You find numbers that are less than below. And so you would shade underneath. And make sure, again, that you are crossing the x-axis, that you're crossing the y-axis. The boundary line is the line y is less than or equal to 4. Okay, so let's do one that's maybe a little bit more traditional. So suppose you were given the inequality x plus y is greater than 3. Now you can build a table. A lot of my students prefer to build a table because that's what makes sense to them. Most of the time, most of your math teachers are not going to bother building a table. They are going to graph using shortcuts because we understand the table, we understand the shortcuts, and it's totally okay to do. So I'm going to go ahead and use the shortcut here and subtract x from both sides. X minus x is 0. And then on my right hand side, I'm going to do negative x plus 3. So you might say 3 minus x, but remember that's 3 plus negative x. And to put it in the form y equals mx plus b, we usually want that x leading. Now, a lot of my students will say, well, what's the slope? What am I supposed to do with that negative x? Well, remember, if you don't see a coefficient, the coefficient is a 1. And so our slope in this case is a negative 1. So let's go ahead and graph it. So we have a y-intercept of 3. And then our slope is negative 1. So you might use negative 1 over 1. So starting at the y-intercept, we're going to count down 1 and right 1. And then that gives us our 2 points for graphing the line. Now, notice the inequality here. It is just greater than. So the line is not included. The line is going to be a boundary, but the line itself is not part of the answer. And so when we do this, we're going to do a dashed line. Okay, now one of the sides is shaded. So either we're going to shade this side of the line or we're going to shade this side of the line. We're going to shade whichever side of the line is true. And so there are 2 ways that you can figure out which side of the line you want to shade. My students tend to prefer what's called a test point. And so it's just basically picking a point anywhere. You can use any point, okay? Any point on the coordinate plane at all, and test that point and see whether that point is true or false. And that will tell you which side you need to shade. Now, because 0 is the best number ever, If the point 00 is available for you to test, that is what you should test. If the point 00 is not available, it means that the line is going through the point 00, and you need to pick a different point, but any point will work. So let's go ahead and plug in the 00. And I get 0 plus 0 is greater than 3, 0 is greater than 3. That is false. So what that tells me is that this side of the line is the side that's false. Because 0, 0, I tested it out, and 0, 0 was false. Which means that this side of the line over here must be true, and we always shade the true side. That's the true side. Now, if you're a little bit shaky, you're like, ooh, I don't know if I buy that. Go ahead and pick a point that's on the true side. Okay, something, you don't want to pick anything like right next to the line because our lines tend to wobble a little bit and your line might not be wholly accurate. But if I came over here to like 1, 2, 3, 4, 5, 6, 7, 8, I'm pretty confident that point is on that side of the line. And so that would be the point 8, 0. So 1, 2, 3, 4, 5, 6, 7, 8, like right there. So we can try out the point 8, 0. So 8 plus 0 is greater than 3. 8 is greater than 3, which is true, which just kind of confirms. And it also reminds you that you can pick any point, like any point at all. 0, 0 is just nice because zeros are nice. But you can pick any point you want. You don't have to pick 0, 0, and you can pick as many points as you need to pick until you're confident that you know which side of the line you are supposed to shade. Now, there happens to be an easier way to figure out which side of the line to shade, and I'll show you what that way is. Let's see, I'm going to do this one. 2x minus y is less than 1. So in order for this other way to work, your line has to be in the form y is greater than less than whatever. Like you have to have it in y mx plus b form. Okay? Otherwise it doesn't work. So you want to make sure you know when you can use this. So we're going to get the y by itself by subtracting 2x from both sides. 2x minus 2x is 0. And I'm going to go ahead and put that 2x in the front there. Now, this is not y. This is negative y. It's actually negative 1y. So I'm going to go ahead and divide everything by negative 1. And remember, that triggers a flip. It triggers a flip on our equation there. So y, and now my less than is going to turn around and be a greater than. Negative divided by a negative is a positive, and a positive divided by a negative is a negative. So I'm going to go ahead and graph that line. So the y-intercept is negative 1, and then my slope is 2, so I'm going to count up 2 and over 2, or over 1, sorry. Okay, and there's no equal to, which means the line is a boundary, but it is not actually included. And so the way we mark that is our two-dimensional version of an open circle. So here's the little shortcut. Once you have it in this form, and you have the y by itself, so you have to have y by itself. You can't have y messing around with other stuff, okay? Once you have the y by itself, y is greater, okay? So picture the y-axis right here, and you think, all right, y is greater than the line. So here's the line. The y coordinates that are true are greater than the line. And that greater than means you shade above the line. And so without doing anything else, I can shade above the line. So I'm going to shade this side, and it's kind of morphing with my work there. But hopefully I made it clear which side you're going to shade. If you're not sure, if you're like, that seems a little bit dodgy, I'm not totally sure, let's go ahead and pick a point that we're sure is in this region. So 1, 2, 3. We'll do the point 0, 3. Okay? And we'll plug it into the original. So 2 times 0 minus 3 is less than 1. -3 is less than 1, which is true. And that will always work. So if you feel a little bit shaky on that shortcut, it's really, really nice. And it means you really don't have to show any work at all for some of these problems. But if you're a little bit shaky on it, like kind of back it up with a test point. So practice using the shortcut like greater than, and then if it says y is less than would be under the line, because that's where you go to from your y coordinates to go to y coordinates that are lesser. All right, and just be careful with that little shortcut too. If like I draw a line that looks like this and I say shade above it, most students don't have any trouble like kind of seeing, oh, like that's above and that's below. But sometimes when the line gets very steep, it's just not as easy to see. Most students will see the left and the right, and they won't see, oh, this is above and this is below, which it is, because if you look at like the y-axis, when you go above greater than, you end up on that side of the line, and when you go below, you end up on that side of the line. So just be a little bit careful about that. What's important is not the way that you're doing it, but that the way you do it makes sense to you and you're able to reason your way through it. So as always, up next is some practice problems. I'll put a few practice problems on the screen and pause the video, work them out, and then unpause to check your answers. Okay, so for the first question, are the points 1, 3, and 2, 0 solutions to the inequality 3x minus 2y is less than 2? For 2 and 3, we're going back to those horizontal and vertical lines, just reviewing those. X is greater than or equal to 5, and y is less than 8. For number 4, graph 2x minus y is greater than or equal to 6. And for 5, graph y minus 4x is less than 0. And for number 6, just integrating a whole bunch of different skills there, write an inequality for that graph. Okay, so notice where those points are, notice what kind of line it is, and then notice the direction of the shading. Pause the video at this time and then unpause it when you're ready to review your work. Okay, so for the first one, it's actually 2 separate problems. You do have to test both points separately, so if that confused you a little bit, it's okay. Like that's what practice is about. Just make that the corrections that you need to your work. The first one, when you plug it in, you do get a true statement. -3 is less than 2, and make sure that you answer the question. So it says like is 1, 3 a solution? To answer that with the word true is a little bit weird, because the way that it's phrased as a yes/no question. And so, yeah, it's true that it is a true statement, but you probably want to answer yes, like yes, it is a solution. 2, 0, when you go to plug it in, you get a false statement. And again, it's really awkward if somebody says, is this a solution? And you say false. You probably want to say no. No, it is not a solution. It's just a more natural answer to the question that's being asked. Next one is a vertical line. X is greater than or equal to 5. And so it's a solid line because it is or equal to. And where do you find X coordinates that are greater? You find them to the right. You find them to the right on the number line. If you were to do this in 1 dimension, it would be just like the solid, like the filled in circle, and then you'd be shading on the number line. And the only difference is that like now it's 2-dimensional, and so you've got like that extra dimension with the y, just the y doesn't matter. Next one, y is less than 8, and I did not dash my line. I was so, here we go, let's go make that correct. There we go. Y is less than 8. The line y is equal to 8 is not part of the solution, so 8 is not less than 8, and that is false, but it does mark the boundary between where you have the points that work and the points that don't work. And so you do need to put the line on there. If you did what I did and you went into autopilot and just made your line solid, you want to dash it. And what I tell my students to do, if they're writing in pen and they've accidentally made something dashed and there's no nice way, or solid, and there's no nice way to make it dashed, to write a little note to me on their test or something that indicates that they understand, like, oops, I made a mistake, I need to make sure this is dashed. And then less than means you're shading underneath the line. For the next one, you can plot graph this by making a table. I did it the way that I did in the lesson. So I subtracted 2x from both sides, and notice that I'm not showing the algebra steps here. Like I'm showing just the process. And so you need to understand that to go from here to here, what happened was I subtracted 2x from both sides. And then to go from here to here, I divided everything by a -1 and flipped my inequality. The y-intercept was -6. The slope was 2, so up 2 over 1. It has an equal to solid line, and because it's less than, I am shading underneath the solid line. You can arrive at that same graph different ways. You can graph the line by plotting points. You can do a test point to figure out which side to shade. There's more than one way to get there. Next one, this one might have thrown you for a loop a little bit, especially if you're used to using 0, 0 as a test point. So I did this again the same way. I added 4x to both sides, and then just so you know how the graph worked here, this would be 4x plus 0, okay? We don't need to write the plus 0 because it's pointless, but the y-intercept is indeed a 0, which means this is a line that goes through the origin. If you blanked out on that, you can always build yourself a quick little table, and you'll see really quick, like, oh, 0, 0 is on the line, and so is the 0.14. Which you can also get by doing a slope of 4, so up 4 over 1. The line is not included, so it is dashed, and the less than means that it is shaded underneath, so underneath the line. If you're not sure of that, go pick a point that's like over in the region you think is the region you're supposed to shade, and just like go and test it out and just make sure that that point is true so that you know you're on the right side of the line. And this one, write an inequality for this. So the way I did this, I was going to go through and like use the formula for slope and go through the process of writing the equation of the line. And then I realized I didn't need to do that. So the slope I just got from counting. To go from one point to the other, I go up 2 and over 1, 2, 3, 4, 5. So my rise over run is 2/5. I didn't need to do anything. And it turns out that the y-intercept is one of the points that we know. So we know the y-intercept is -2. So if I've got y equals mx plus b, I can just plug in the 2/5 and plug in the -2, which gives me the equation for the line, which is not quite the answer, because not only do we have the line, but we have all of the points on one side. So over here, I have a little bit of thought process. The solid line means that we're going to retain the equal sign. And then the fact that we're shading above the line means that we want y coordinates that are greater. So instead of an equal, what I want there is y is greater than or equal to 2/5 x minus 2. So that wraps up our lesson on two-dimensional inequalities. There are some pretty fun examples with this. We're going to revisit it in our next unit, which is on systems of equations. We're going to do some systems of inequalities. So hang on to this piece of information for at least one more unit, and I'll see you in the next lesson.